Alright, so in this video we're going to talk about absolute extrema. We'll start with the definition. So f of a is an absolute maximum of the function f of x if f of a is greater than or equal to f of x for all x in the domain of the function. And the domain can be either implied or explicit. Okay, we have a very similar definition for absolute minimum. So absolute minimum is the same with f of a is less than or equal to f of x. Okay, so let's talk about maximizing or minimizing functions. So to find these absolute maxes or mins, we don't only look at the critical points like we did with local maxes and local mins. We also look at the endpoints. If there are no endpoints, we consider the end behavior of the domain. All right, let's do an example. Call this example 1. So let's find the max min, absolute max and min of the function x cubed minus 12x. And we're looking at the interval over the interval 1 to 3. So first thing we're going to do is take the derivative and set it equal to 0. That's going to give us our critical points. If we factor, we'll get 3 times x squared minus 4, or if we factor again, we'll get 3 times x minus 2x plus 2. So this gives us 2 critical points, x equals 2 and x equals negative 2. So our critical points. We could also have a max min at the endpoints, so we need to consider the endpoints. So what we're going to do is we're going to take the critical points and the endpoints and we're going to plug them all into the function. So we're going to evaluate f at 1, the first endpoint, evaluate f at 2, and evaluate f at 3. And we're going to ignore this negative 2 because it's not in the domain. If we put 1 into our function, we'll get 1 cubed minus 12 times 1, which is negative 11. If we put 2 into our function, we'll get 2 cubed minus 12 times 2, which is 8 minus 24, or negative 16. If we put 3 into our function, we'll get 3 cubed minus 12 times 3, which is 27 minus 36, which is negative 9. And so our max is going to be the biggest of these values. This is our absolute max. And our min is going to be the smallest of these values, absolute min. If we draw a picture of this function, we can see why this is the absolute max and absolute min. So our cubic function looks like this. And it outputs at 2, negative 16. It outputs at 1, negative 11. And it outputs at 3, -9. So we're only looking at these values from 1 to 3. So on this domain, the min is going to be this -16, and the max is going to be this -9. All right, let's do another example. Call this example 2. So in this example, we're going to find the max and the min of g of x defined by 1 over x plus x over 4. And we're going to be looking at this over positive x. Okay, so let's start by taking the derivative. So the derivative of 1 over x is -1 over x squared by the power rule, and the derivative of x over 4 is 1/4. Setting this equal to 0 and solving for x, we get 1/4 equals 1 over x squared, or cross multiplying x squared equals 4. So x equals 2 or -2. We're going to ignore that second value because x is greater than 0. All right, and so now we just have one critical point, x equals 2. And so to analyze the endpoints, we're going to consider the end behavior. Consider the end behavior of g of x. So this interval is 0 to infinity. So the ends are 0. That's one end. And infinity is the other end. So we can't put 0 and infinity into these functions. They're not in the domain. But we can take the limit as x goes to 0 of this function and the limit as x goes to infinity, and just see what the function's doing as we approach those endpoints. So if we take the limit as x goes to 0 of g of x, we're taking the limit as x goes to 0 of 1 over x plus x over 4. As x goes to 0, look at 1 over x. 1 over x is going to blow up. So this is going to be infinity, and the x over 4 is going to be 0. Technically, we should be taking the limit as x goes to 0 from the right. And we're seeing that the outputs blow up. Okay, and then if we take the limit as x goes to infinity of 1 over x plus x over 4, the 1 over x goes to 0, and the x over 4 goes to infinity. So in both cases, we're going to infinity. This means that there is no absolute max, no number that all numbers are below, all other outputs are below. So let's consider g of 2 now. We'll get 1 over 2 plus 2 over 4, or 1/2 plus 1/2, which is 1. And this is going to be our absolute minimum. If you sketch g of x over the domain, you would see that it indeed has this minimum at the point 2, 1. This is our absolute min. And there's no max, no max. All right, I hope you found this video useful.